Hello, my name is Rob Reynolds. Welcome to Mat-073. Today we're going to be looking at section 7.4 and discussing the discriminant, which you'll discover is the b squared minus 4ac portion of the quadratic formula. And then it has three outcomes. If it's positive, it has two solutions. If it's negative, it has no solutions. And then if it's a zero, it has one solution. So again, solutions are the nature of the root. So here's a 2 solution, which means the discriminant is positive. If the square root is negative, which means it's an imaginary, which means it never crosses. And then if the discriminant is 0, that means that there's one solution, and that means there's a double root at the x-intercept. It's bouncing. So we're also going to be looking at how to solve quadratics using u-substitution in this video. So again, the discriminant is the b squared minus 4ac. If you remember a previous video, x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So we're looking just specifically at what's underneath the radical. You don't take the square root of it. It's the value that's underneath the radical is the discriminant. So again, talking about the nature of the roots, if the discriminant is 0, that means that the graph will come down and there will only be one solution. So it only crosses once. This is an x and y axis. If it's positive, that means that it will cross 2 times. So there's 2 different real solutions. And if it's negative, that means that the graph never crosses the x-axis and there's no solutions. So to determine the nature of the roots, we'll identify the values of a, b, and c, just like we did for the quadratic formula. But instead of plugging into the quadratic formula, I'm going to plug into the discriminant formula, which is b squared minus 4ac. So the discriminant is equal to negative 10 squared minus 4 times 5 times 5. In this case, we'll get 100 minus 100, which is 0. And so that means that the function has only one solution. So if the discriminant is 0, it only crosses once, so it's on the axis. So you could graph this and check this on your graphing calculator, but if the discriminant is 0, there's only one solution. Again, the value of a is 4, b is negative 1, and c is 1. So the discriminant, b squared minus 4ac, is negative 1 squared minus 4 times 1, which is 1 minus 16, or negative 15 if it's negative. That means I don't know where the graph is, but there's no solutions. So it's not crossing the x-axis at all. So negative 15, the discriminant is negative, which means there are, well, this says 2 non-real complex number. That means that it's like plus or like 5 plus or minus I square roots of 3 or something divided by 2. They're imaginary. So imaginary roots do not cross. So we can always go backwards. If I give you a function like x squared minus 5x plus 6, we're used to solving for this by factoring it. Factors of 6 that add up to 5 are 2 and 3. Signs are alike. They're both negative. And then we could say x equals 2 and x equals 3. Well, now we're going to go backwards. If x equals 2, that means I could write the factors. And if I have the factors, I can multiply those together or use the FOIL method and find the function. So if 1 is a factor, then x minus 1 is a root. And if negative 4, then x minus the negative 4 is also a root. So here comes a definition. The factor is always x minus the root. And of course, x minus the negative 4 is the same thing as x plus 4. So there is a great function with 2 roots, and then you can FOIL that back together. So here comes an example. If 5 is a root, then x minus 5 is a factor. And then x minus 4/3 is also a factor. Now, by definition, we can't have factors that aren't integers. So if x really does equal negative 4/3, I could multiply both sides by 3 because it's a nice equation here. And so I get 3x is equal to negative 4. And then if I add 4 to both sides, instead of equal to 0, 3x plus 4 also equals 0. So you can see that this root is going to be negative. So instead of writing this as x minus 4/3, I'm actually going to write this as a 3x plus 4. Both of these factors have the same root of negative 4/3. I would just prefer to write it as 3x plus 4 because then I'm not violating my rules of integers for factors. So you can't have a fraction, so you need to get rid of this 4/3 as a root, and 3x plus 4 accomplishes that. So then I'll use the FOIL method. First terms, outer, inner, and last. So 3x squared, the outer is 4x minus 15x for the inner terms, and then the last is minus 20. Combining, I'll end up with 3x squared minus 11x minus 20. And again, you could graph this for a quick check to see if it really does have intercepts of 5 and negative 4/3. That's easy to check on your graphing calculators. If you have imaginary roots, the process is the same. It's x minus the root, and x minus a negative 3i is positive 3i. So this is a conjugate, meaning changing the middle sign. So all I have to worry about is the first and the last, because the outer and the inner terms should drop out. So the first terms is just x squared. You can check the outer and inner terms if you'd like, but it's just 3xi and a negative 3xi. The last term is minus 9i squared, and in a previous video we learned that I squared is really negative 1. So this final solution is just x squared plus 9. The last part of this video is going to be talking about how to solve non-quadratics, but we're going to treat them like quadratics. So even though this is an x to the 4th, we're going to pretend like this is in quadratic form as x squared quantity squared minus 5x is being squared as well, plus 4. So we can kind of pretend like it's in x squared form by doing a u substitution. So if we replace x squared, and we do a little let u statement. So if we let u be x squared, then if I square both sides, I'll get u squared is equal to x to the 4th. So my new problem says let's replace x squared with just u. So this becomes minus 5u plus 4. And then this u to the 4th, which is this term, just becomes a u squared. And so this is easily factored. So that's what they're explaining here. Even though it's an x to the 4th, I can treat it like an x squared term. And then go ahead and solve this as a u substitution problem. Let me give you an example here. Again, you just go for this middle term, and we usually let this be the u term. So I'm going to let u be x squared, and then if I square both sides, I'll get u squared to be x to the 4th. So I'm going to replace u squared with x to the 4th. They're equivalent according to my definitions. So I'll say u squared minus 5 times u, because, well, I've just replaced u with x squared. And I'll say plus 4 equals 0. So I'm going to factor this. Factors of 4 that add up to 5 are 4 and 1. Signs are alike, they're both negative, u minus. So I'll get u equals 4 and u equals 1. However, u is not what I was trying to solve for. I was trying to solve for x, but I have a nice definition to replace u back with x squared, because u equals x squared. So every time I see a u, I'll write x squared. And let's solve for x now by taking the square root. And if you remember, if you take the square root of both sides, we end up with 2 answers. So plus or minus 2, and x equals plus or minus 1. So I actually have 4 solutions here. And here are all 4 solutions. So be careful. The last step sometimes is often missed, and that's what this caution is talking about. Make sure that you're solving for the original variable and you don't stop with your u equals statement. So again, usually, not always, we let u be this middle term. the square root of x. How do you know if that works? Well, I'll just square both sides and see if I don't get this term, which I did. So now I've got a nice definition. U squared minus 8u minus 9 equals 0. Factors of 9 that differ by 8 are 9 and 1. Signs are different. The larger term is negative. So I'll get u equals 9 and u equals negative 1. Plugging back in for the definition of u, the square root of x is equal to 9. So squaring both sides means x equals 81. Now, when I write this statement, the square root of x equals negative 1, I know that that does not exist because there's no number that I can take the square root of and get a negative. If you didn't recognize that, again, we could just square both sides and get x equaling 1, and then I could check 1 to see if it really worked or not. So 1 minus 8 square roots of 1 minus 9. Does that equal 0? And the answer is no, it does not. 1 minus 8 minus 9 does not equal 0. So that's called an extraneous solution. I just throw that out. So the only solution here is 81. So the only solution that we get here is 81. Last example, I'm going to try this same thing because it's been working for me pretty good. I'll let u equal t to the negative first. Squaring both sides, that means u squared should equal t to the negative second, because t to the negative first squared is a power raised to a power rule, and that's t to the negative second, which is exactly what I wanted. So I have a u squared plus 4u minus 2 equals 0. Unfortunately, there are not factors of 2 that differ by 4. So I'm going to have to do the quadratic formula here. And instead of saying x is equal to, I'll say u is equal to. Still negative b plus or minus the square root of b squared minus 4ac, all divided by 2a, where the value of a is 1 right here, the value of b is 4 right here, and the value of c is negative 2 here. So u is equal to negative 4, that's right here, plus or minus the square root of 16 minus 4 times 1 times negative 2, all divided by 2 times 1. So negative 4 plus or minus the square root of, and again, I would just take a calculator and type in this. 16 minus 4 times negative 2 is 24. I'm going to simplify 24 to be the square root of 4 and the square root of 6, and rewrite this as negative 4 plus or minus 2 square roots of 6 divided by 2. And again, we cannot cancel part of a sum, but I can cancel both sums. So I'm going to divide everything through by 2. Negative 4 divided by 2 is negative 2. Plus or minus the square root of 6 for final answer. But remember, that was what u was equal to. And I'll go back to my definition, and it says u is really equal to t to the negative first, which you may recognize as 1 over t. So I'm going to replace this with 1 over t is equal to negative 2 plus or minus the square root of 6. And then if I take the reciprocal of both sides, which I can do that, I can do whatever I want as long as I do both sides, and that's the reciprocal function. X to the negative first says take the reciprocal. Remember, 2/3 to the negative first is the reciprocal, which is 3/2. So the reciprocal of 1 over t is just t, which is really what I wanted to solve for. And the reciprocal of junk is 1 over junk. So there's my final solution for t. And here's how the author chose to solve for it. Remember, this is the value of u, so you're not done. You need to go back and actually solve it for t. If you have any questions, feel free to email me. Thank you.